Okay, good morning. Today we are continuing working with those factors. Today we are doing CO23. I can find the greatest common factor of a set of numbers. So we're going to be looking at all of those prime factor pairs, or not prime factor pairs. Like in yesterday's objective, we had to write factor pairs that got us to that number. So we're going to be looking at all of those factors that go into numbers, and we're going to compare them with another number to see what the greatest factor that they both share. So to do that, we need to know what the factors are. Factors are numbers that go evenly into a given value. So no decimals. You have to be able to break your number down evenly. All right, so when we had that 10, it was 2 times 5 that we would break that 10 down to. Right? It has to go into them evenly. So an example, 2 and 9 are factors of 18. 6 and 5 are factors of 30. Okay? They don't have to be prime factors. Just any factor buddies, any factor pairs that go into that first main number. So there are 3 methods we're going to go over using this. The first one is that prime factorization like we did yesterday. So let's just cover this up. So if we use prime factorization, let me move it up a little bit. We are going to make those factor trees for both sets of numbers. So for 18, we could break 18 into 2 and 9. Then that 2 is a prime, it comes straight down. The 9 gets broken into 3 and 3. So we have these prime factors for 18. For the 15, we break down into 3 and 5. So we have those prime factors. I'm going to look to see what my prime factors are. The biggest, they only share one factor. 1, 3. So I can say they share this 3 and this 3 from the 18 and the 15. So I know my greatest common factor is going to be 3. Let's look at 42 and 30. What could I break 42 and 30 into? Who can tell me a factor pair? Sarah.
6 and 7.
6 and 7. We know 6 times 7 is 42. Is 6 a prime number?
Yes.
I can't break 6 down any farther?
2 and 3.
Oh, I can break it down farther, so no, it's not prime. I want to break it into my primes of 2 and 3. Is 7 a prime? 7 is a prime. I can't break 7 down any farther. So I have 2 times 3 times 7 would get me to 42. Now I'm going to make my factor tree for 30. What factor pair could I use, Nolan P?
6 and 10.
Not 10, because that would be 6 times what would give me 30? 5. So 6 times 5 is 30. Just like we broke the 6 down for the 42, I'm going to break my 6 down with that 30. 5 is a prime. So I have 2, 3, and 7, and 2, 3, and 5. So I'm going to say they share a 2. So I'm going to write my 2. They also share a 3. So any primes that they share, I multiply together. So the greatest common factor that 42 and 30 share is 6. They share the 2 and they share the 3. So I have to multiply those 2 primes together to get my 6 when I use prime factorization. So let's look at doing it with our 3 numbers. We have 12, 30, and 60. What could I break my 12 into? Adeline? 6 and 2. And we know from over here I can break that 6 down into 2 and 3. 2 is a prime, so that comes straight down. Now I have 30. We just broke our 30 up over here. I'm just going to use the same ones. That 6 we can break down into 2 and 3, and the 5 comes straight down. Then I have 60. What can I break 60 into, James?
20 and 3.
20 and 3. 20 can be broken down into what, James?
10 and 2.
And 3 is a prime, it comes straight down. 10 can be broken into what, Adeline? 5 and 2. Now what Adeline just said is a very, very common mistake that people make. A lot of times people will put what we add together. So she first said 5 and 5 because 5 plus 5 is 10. We have to be very, very careful that we are putting down the multiplication. Okay, what is its buddy for multiplying? So it would be 5 and 2. Our 2 is a prime, that comes straight down. Our 3 is a prime, that comes straight down. So now I'm going to look at all 3 numbers and what factors that all 3 of them share. I see a 2, and a 2, so I'm going to write that 2 one time. Then I see a 3, 3, and 3. I'm going to write that 3 one time. I have a 2 and a 2, but 30 doesn't have a number 2 listed. Right? We've already used this 2. We can't use it again. And that's all that we have left for 12. So that 5 and 5 are only with the 30 and the 60. It's not with 12, so I can't multiply that one through. So I am just going to multiply 2 times 3, and I'm going to come up with the greatest common factor of 6 again. So we have to be careful that all 3 numbers share a factor. We circle it so we don't reuse that number again. James?
So is it just like you're finding the pairs into it? Or like...
To break it down,
Yeah.
we're finding the pairs all the way down to the primes.
But then how do we find the factor that equals 6? Can we just like...
You have to look at which ones they share. That's why I circled the 2, and I wrote it here, because they all shared a 2.
Okay.
Then they all shared a 3, so I wrote that one down. There is no other number that all 3 share.
Okay.
So I can only use the ones that I circle, that all 3 of them shared. Then we multiplied those factors together, and that's how we got 6. How are we feeling about the prime factorization? Okay. It'll come a little bit easier the more we use it. We have another, this way. Another method is the listing method. So we're going to list all of the factors of the number. So I have 25 and I have 40. So for 25, I know it's 1 times 25, 5 times 5. There's no other factor pairs for 25, just those 4 numbers. Then for 40, I have 1 times 40, 2 times 20, 4 times 10, 5 times 8. Those are the only factor pairs for 40. So I'm going to look to see what's the biggest factor that they both share. Obviously, they both share the 1. Our next number up is the 5. They both shared a 5. My next number is a 25. 40 doesn't have a 25, and that's all the factors of 25. So my biggest, greatest common factor between 25 and 40 is going to be 5, because that's the biggest factor that they both share. So let's look at 24 and 36. What are my factors, my factor pairs for 24? James?
6 times 4.
6 and 4. What's another factor pair for 24? Bridget? 12 and 2. What's another factor pair? Adeline? 1 and 24. What's another factor pair, Emerald? 3 and 8. Are there any more? Nope, that's it. So now we're going to list all the factor pairs for 36. What are some? Emma? 1 and 36. What's another factor pair, Bridget? 6 and 6. What's another factor pair? There's a few more. Who can find them? Liam? 4 and 9. What's another factor pair? Nolan?
2 and 18.
2 and 18. One more factor pair. Hudson, do you got it? 12 and 3. So now I'm going to look at all of these pairs and I'm going to see which is the biggest factor that they both have listed. So we've got the 1s, okay, we've got 2s, we've got 3, we've got 4, no 5, we've got 6, no 7s, we've got an 8 here but no 8 over here. We've got a 12 here, but no, oh, we've got a 12 here. And then we have a 24, but no 24 here. So that biggest number that they both shared, I went all the way up to 12. Notice how I was kind of marking off as I got to them, so I could see if they shared that number or not. So then each one that you marked off, you look to see what's the biggest number at the end that they both shared. So let's do it with 3 numbers now. 8, 16, and 48. What are my factor pairs for 8? Emma?
2 and 4.
What's another one? James?
1 and 8.
1 and 8. And that is it for the 8s. What are my factor pairs for 16? Lexi?
1 and 16.
What's another factor pair, Aiden? You were close. That would have gotten us 18 though, not 16. Can you think of a different one that gets us to 16? 4 and 4. What's another factor pair, Kellen? 2 and 8. And that's it for our 16s. What are my factor pairs for 48? Bennett?
There's another one. No.
Adeline?
6 and 8.
6 and 8. What's another one? Emma? 1 and 48. What's another one, James?
12 and 4.
What's another one? 48 is an even number. Hudson?
24 and 2.
24 and 2. 4 plus 8 is 12. So 12 is divisible by 3. So what's another factor pair for 48? James?
3 and 16.
3 and 16. So we've got the 2, 3, 4, no 5, 6. 7 doesn't go into it. 8. Can 9 go into it? 4 plus 8 is 12. Nope, that's not divisible by 9. Doesn't have a 0 or 5 at the end. This is all of my factor pairs. So what's my next step? Adeline? Check the biggest number that goes into it. So they all have the 1. This one has a 2, this one has a 2, this one has a 2. I see a 4, 4, and 4. And then we have 8, 8, and 8. And that's it for the 8s. So it has to be 8 because I can't go any bigger. Oops. Any questions on the listing method? Okay. So you can find greatest common factor using the prime factorization, making those factor trees. You can list out all of the factors, The trouble with listing out all the factors is sometimes we might forget a factor pair. Okay, what if you forgot to put the 4 times 12? You might not have gotten there. So you have to remember when you're listing out your factor pairs that you list every single one. Our last method to use is the table method. So we put both numbers, 21 and 35. We're going to make a table. I'm going to look to see what prime factors I can pull out. I know I can pull a 7 out of 21 and I can pull a 7 out of 35 because they're both multiples of 7. So if I take that 7 out, 21 divided by 7 is 3. 35 divided by 7 is 5. Is there another number that I could take out of 3 and 5? James? The only number that could come out of both of them is a 1. And that 1 doesn't count because it's going to leave us with the 3 and 5 still. So that number, I just pulled out one number, so my greatest common factor is going to be 7. If we look at 15 and 50, I'm going to make my table. I'm going to put 15 and 50 at the top. What number can I divide out of both 15 and 50, Nolan? I could divide a 5 out. 15 divided by 5 is 3. 50 divided by 5 is 10. Is there a number I could divide out of both 3 and 10? Sarah, is there a number I can divide out of 3 and 10? There's not. Right? That's as low as I can go. So all I have over here is just that 5. So that is my greatest common factor. So let's make another table for my 14, my 28, my 49. What number can I divide out of all 3 of those numbers? Emma? I can divide a 7 out. 14 divided by 7 is 2. 28 divided by 7 is 4. 49 divided by 7 is 7. Can I divide another number out of 2, 4, and 7? No. So my greatest common factor here is 7. What if I can divide more out? So let's look at 24 and 36. If I use those for my factor table, 24 and 36, what number could I divide out of both 24 and 36? Give me a small factor I could divide out. Bridget?
6.
Give me a small factor. Oh yeah, 6. 6 is smaller. So what's 24 divided by 6? It's going to be 4. What's 36 divided by 6?
6.
6. Is there a number I can divide out of 4 and 6, Sarah?
2.
I could divide a 2 out. So I could go down even farther. 4 divided by 2 is 2. 6 divided by 2 is 3. Can I go down any farther? No, I can't divide anything else out of 2 and 3. So I'm going to take both the numbers that I pulled out and I'm going to multiply those together. So any of the numbers that we pull out, we multiply together. So 6 times 2 gets me to that 12. So sometimes it'll be easy and we just have to pull out one number. Sometimes we pull out multiple numbers, then we have to multiply everything on that left side we multiply together. Does that make sense? Okay, so let's look at our second page. You're going to pick which method you want to use to find your greatest common factor. Show your work. Are you going to use the prime factorization? Are you going to use the listing method? Are you going to use the table method? Whichever method you use, you have to show the work you're doing. You cannot just look at it and say, I know my math facts. I know this is the biggest number that can come out of both, and I'm just going to write it. That's not practicing, okay? No gold stars for mental math. I need to see the work of whichever method you're using. Lila? Nope, you have to use one of these three methods. And then come up and show me what your method is, okay? Then we have some word problems that you need to answer, and we have our review problems, okay? Any other questions? All right, if you are watching this from home, I hope you are well, and I hope to see you soon. Make sure you see me if you have any questions. Have a wonderful day.